Hi, I'm Alice. Thank you so much for clicking on my link. I'm gonna be talking about bits and qubits today, and they're the fundamental pieces of our computer and future. And let's start. So, to understand what a qubit is, we first have to understand what a bit is. Its simplest definition is it's zero and ones that make up everything in our computer. And just like atoms in our world, instead, bits are the untrustworthy part of the computer world since they make up everything. And they're the little switches, and every letter you type, every picture you upload, every frame you watch, and even this video and the voice coming out of your phone or your computer are all made up from those zeros and ones. And then they're basically the basic unit of information. And how is a qubit different? So a qubit is the basic unit of quantum information. And instead of two states, 0 and 1s, that our switches can have, qubit has this quantum characteristic that it can have infinite many states. As we see in this figure, a qubit it can represent a vector from the center of a sphere, and then it points to anywhere on the surface of the sphere. By the way, this is a unit sphere with radius 1, and it's constrained to the surface too. We'll talk about a little bit later a little bit too. And one type of a qubit is an atomic nucleus, which is the orientation of its magnetic moment, which is its spin, as we learned in chemistry. Spin can point in different directions in relation to a magnetic field, such as up or down, or sideways, or certain angle, which represent by the vector. And so the two basic states of a qubit or vector are 0 and 1, and a matrix they're represented by 0, 1 and 1, 0, the two bases, the elementary bases of R2 space. And qubit, instead of only having those two states like a normal bit does, qubit have this complex state which was represented by a linear combination of matrix that represent 0 and matrix that represent 1 with coefficient alpha and beta. And alpha and beta, as I talked about before, are constrained to the surface of the sphere, which we don't want. They can't go out or shrink in. And how would we use qubits? So one way of using qubits is to form a quantum computer, and I explained that a little more in a longer video, and a link will be provided. But let's just use this brief example of Groove Research. Groove Research is an algorithm that IBM, a company that also works on quantum computers, use it's very simple to find one item from a list of n items. And normally when you check n divided by 2 elements on average. However, using Groove Research, we only need to find roughly square root of n of the list, and the qubits, or the form of quantum computer, enable that algorithm to work. And according to IBM, if you want to find one item in a list of 1 trillion, a classic computer will roughly take 1 week, while quantum computer using this algorithm will roughly just need 1 second. And this opens up so much more probability for us in the future. And also, if you want to know more, click on my link. And thank you so much for listening to this brief explanation.